So our TA posted the rule for the CSE373, the homework grading. So first one and until the 10th one, we're going to have a task 1 and 2 as a 0.5 point each, and task 3 will be the 1 point. And you should submit your own work. If not, then you have to face the consequences. Okay, after 3 days, we will not accept any submission. And 10% point deduction per day. Okay, so 5 minutes late is 1 day late. So use this rule. And resubmitting work policies, if the resubmission was made on time, then the TA will check it, the time, and count it as a check the time, and take the following actions. And if the resubmission made was after the due date, then he will only check the latest one, and the late time will be counted. Okay, any comment about the your homework? And I believe you collected your the homework scores.
Yes, we checked it. I checked it.
Okay. All right. Some of you joined the late, but while you are not there, so we talked about the homeworks, and we read through the grading policy, which is posted on the Google Classroom. Okay, so TA's work is only 10 to 20 hours a week, meaning he cannot spend whole time on it. Okay, if you keep asking the problem, please use the Google Classroom, then everybody can share. Maybe if you can defense, or if you comment the someone else's question, that is fine. Okay, then we can share all together what is the issue, how to solve it. Okay, so please solve your please solve by yourself, and please upload your original work. If not, it won't be good. All right. Any comment about the homework? No. How was the homework? Too easy?
I think it was well designed.
Okay, thank you. Okay, so the homeworks are not based on, I'm challenging, but to help you understanding. Okay, so I'm choosing the very famous questions, meaning the solution will be available on the internet, but I don't want you to copy that. I want you to think about it. The solution is very simple, and how we approach is all about the 373. Good?
Good.
All right, so if you have a difficulty in solving the problem, please contact your fellows, your friend. This is a very good time to make a new friend. Okay, if not, and maybe you can post on the stream. If you want to solve it together, let's do it together on the stream. And you guys can chat over the line, over the online, or you can physically meet it if your group is small enough. Okay, don't struggle yourself, and talk to someone is very helpful. All right, you guys are reading a books? 373, I have 2 books.
Professor, some students are not, they can't come into the class. Can you allow them to?
Oh, you mean Ha-sung Jun?
Yes.
I accepted multiple times, but okay, now he's in. Okay, so this is the book. I'm sure you get the PDF version. It's not that hard to find the PDF version, right? You can pay if you want to, but there is a many other way to reach the PDF. Any comment about your homework? And make a good friendship. And if you copy from the previous years, and we'll check it later, if you copy, the old score related will be 0, and you have to face the consequences. Please not copy from the previous years. And I'm keep making the new and original problems. Okay, so exams will never be drawn from my previous and never be drawn from someone else. And I'm making my own problem usually. Okay, any comment about the homework or exam? And some of you submitted the over the email, but this is our policy. And our TA is working hard, and resubmission is not allowed after 3 days. What's the point of it? Okay. All right, so let's start the class. So how about the time sync? Let me try to, hello, okay, hello. So in the morning I had a time sync issue, but this afternoon is fine. I don't know what has changed, but it is fine. Okay, so problem day. So after the lunch, we need to warm up our brain. So let's solve this problem. So find the two functions f of n and g of n that satisfy the following relationship. If there is no such f and g exist, write none. So problem 1, big set out of gn, f of n is big set out of gn, and f of n is not big O of gn. Okay, problem 2, f of n is big omega of gn, and f of n is not big omega of gn. Let's think about for 5 minutes, and we're gonna discuss about it. So now I'm gonna pick someone who's not presented yet. Okay, all right, so prepare. And if your mic is not working, please test it before you present it, okay? So I'm gonna ask you a question to Bae Yu Ha and PK and Kwang Min and Yura Kim, 4 of you. Okay, you are selected because you didn't present it yet. Okay, giving more chances to everybody. All right, let's think about for 2 minutes. Ready? Okay, start with the Yu Ha. Okay, I'm sorry, I can't hear your voice. Okay, can I move to the next? I can't hear you. I think everybody else cannot hear you from me. So PK.
Can you hear me?
Yeah.
I'm not sure because
Don't worry.
I think my answer is a none because
First one is
Fn
none.
is n squared and Gn equal to n. So I think
Okay.
that is none.
Okay. Second one.
Second one I couldn't figure out. Yeah. I think it's
Couldn't
none
figure
too.
out. None too. Okay. Next. Next will be okay. Kwangmin.
For the first one, I also said none. And for the second one, I said f of n is the upper bound of g of n.
Oh. So question is, find two functions, the examples, find two functions, f of n, g of n, that satisfy the following relationship. You have to give me an example of it. Okay, then Yura.
Can you hear me?
Yeah.
I think first one is none,
Okay.
and second is Fn is n square, and Gn is n.
Yura, first one, none. Second one is
F1,
f of n,
Fn is equal n square,
n squared.
and G of n is n.
Okay. All right. Okay, Yura made a good point. Thank you. So let's read the question again. Find the two examples, f of n and g of n, that satisfy the following question. So first one, big set of gn. Oh, f of n is a big set of gn. What does this mean? F of n, g of n has a C1 and C2, meaning there is a big omega and big O at the same time. Then I can say zeta. Therefore, f of n is not big O of gn, is not possible. Okay, then we have to say this none. And second one, f of n is big omega of gn. Okay, g of n is my lower bound, right? So this is f of n and g of n. And f of n is not big O of n, meaning f of n, g of n is only the lower bound, not upper bound. Now, example, something like f of n is n squared, g of n is n. What else could be? So how about this? F of n is n squared, g of n is c n squared. Does it work?
No.
No, why?
I think yes.
Okay, who think it is yes or no? So we have to
think
read through.
I think it still works.
It works. Okay, so point is, it is only big O of n, but not big O, only omega of n, not big O of n. Meaning, if I have a c, I can update the c to c2, right? Then in this case, I could be a big O of n. At the same time, I could be an upper bound of it with a different c, right? Therefore, the condition says f of n is big O of gn, f of n is not big O of gn. So it should be completely different like this on the left side. So n squared and n squared, we can't, this is not satisfying. Everybody clear on this point?
Clear.
Okay, thank you. So today we're going to talk about the very basic elementary structures. You understand the computer list, you understand the array, you understand the queue and stack, right? So mankind progress is measured by the number of things we can do without thinking. Okay, so maybe 100 years ago, how can I get to the New York from Seoul? 100 years ago, I have to think more and more. How can I get there first? I have to go to the Japan first, maybe take the big ship, and from there take a month to the LA, then from the LA to travel all the way, then take a maybe months, the seasons, you'll see the seasons over the ship, right? How we do? Buy a ticket on the internet and be there on time at the airport. Then that's it. In 12 hours, you'll be in New York. You can do very simple if you compare to the previously. So you know the Mountain Everest was only 1 or 2 people were able to reach the pinnacle, able to reach at the top, and they set the flag on it long time ago, let's say 30 years ago. And their names are, remember, do you know how many of them are reached these days? 1,000 of them. How that is possible? Because mankind set the base camp up above here, so many people can reach there. From there, the trips are much simpler. Then we can reach our goal more easily. Long time ago, I have to start from the very beginning, and from there, I have to solve all the problem. Then from there, again, it's too tough. So mankind's progress is measured by the number of things we can do without thinking. Okay, I can do plus and minus without thinking. I can do multiply and division without thinking. I can do Python programming with small thinking, but I can use the list without thinking. But I just call the library. I can use a stack without thinking. I can just use a library. That's the Python. That's how the Python is so successful. Okay, so elementary data structures such as the stacks, queues, lists, and heaps are off-the-shelf components we build our algorithm from. So when we talk about the stack, we are just using the library of the stack. Okay, unless unless you need the special functions of the stack, we are just able to use a stack. Okay. So there are 2 aspects of the data structure. First, abstract operation, which is support, and implementation of these operations. We're going to cover today. So data abstraction. We can describe the behavior of our structure in terms of abstract operation and why we can use it without thinking. So push in the stack. How does the push work in the stack? Push 1, then it will be here A, B, C. I can do push A, push B, push C. Then stack will be like this. The next step will be pop. Pop my stack will result in C. Again, sequentially, pop, stack, result in B, pop, stack, result in A. Oh, I can do this without thinking. And this abstract meaning, abstract representation, well explains how does it work. And we are computer scientists. Okay, we have ability to this. Push X element out of my stack, insert item X at the top of the stack, and pop out of stack, returns, and remove the top item of the stack. Okay. There are different implementation of the same abstract operation, enables us to optimize performance in different circumstances. In a C++, it may be written in different way. In a C, it may be written in different way. In MATLAB, it may be written in different way. But it all does the same thing. Okay, it's common thing. When you talk about stack work as our abstract meaning, abstract data structure. And let's see the contiguous and linked list. What is a contiguous? Contiguous, something like array, linked data structure is like a linked list. We're gonna cover it today. And data structures can be neatly classified as either contiguous or linked depending upon whether they are based on array or pointers. So arrays are usually contiguous, pointers are usually linked data structures. The contiguously allocated structures are composed of the single slabs of the memory and include array, matrix, heap, and hash table. Let's say your computer memory look like this. It all has memory. It all has addresses. From, let's say this is 0, and this is n-1 and n-1 point. Okay, so simplify. If you're using only one dimension, this is address 0. This is address n-1. Okay, that is contiguous. So linked list. If you implement a linked list on an array, what you have to do, what's the next value of it? What's the next value of it? What's the next value of it? And what's the next value of it? And what's the next value of it? Do you understand what I draw? So we're gonna cover it in detail about this. So linked data structures are composed of multiple distinct chunks of memory bound together by pointers, include list, trees, and graph adjacent list. Okay, so array, let's look at the array first. Array is a structure of fixed size data records such that each element can be efficiently located by index or equivalent addresses. So array, you may think of, I assume you understand what is array, right? Can I? Who's not clear about the array? Nobody, right? Okay, silent is agree. So let's say my information is stored A, B, C, D, E, and G sequentially. Okay, so my address, if I go to the address 0, I'm expecting A. So what if I go to the hop 3, what's the value expected? Oh, I know what is, I can expect it as D. Okay, so address is expectable when it is older. Okay, advantage of the contiguous allocated array includes constant time access given index. An array consists of pure data, so no space is wasted with links or other formatting information. So just information is there. How can you implement this in the linked list? Then I have to do, let's use this one. So information, and who's my next? Information, and who's my next is implemented. Okay, so I have to have 2 information. In here, array is only 1 information, value self. So I can estimate, and it's all coordinated according to the address. Address itself is index. This guy is value, and index you have to search it. Okay, physically contiguous, physically continuity, memory locality between successive data access helps explore high-speed cache memory on a modern architecture. So this is for high speed and not adequate for big data. And we're gonna talk about why it is in the following slide. Let's talk about dynamic array. So array, once you declare array, it is not possible to increase the size of array. So if I reframe it, unfortunately, we cannot adjust the size of simple array in the middle of program's execution. So we have to declare, okay, my array A is size 10. Then my array is fixed in this size. Then I can play it. Oh, I need the 11th position. What can I do? In a given array, I can do nothing, right? Then stop the execution. Then I have to make it bigger, then copy all the element again. Then A is a 20. Then I can handle the 20. That the stop and processing it takes a long time to do this. So it is not efficient. So array looks very fancy, good, and simple, but its size is limited. What if I declare, okay, A is 300. Oh, I don't need to worry about the size, doubling it or make a bigger size array. But what if you are declare 300, but you are only using first 20 of it? Meaning you are wasting 280, which is very inefficient. Okay, all these 280 positions are assigned but never used. Okay, in a computer world, that is very inefficient. So compensating by allocating extremely large array can waste a lot of space. With a dynamic array, we can start with the array size 1 and doubles it to the 2 times. Each time we run out of the space. But it is also not that efficient because you have to stop, make it bigger, and keep continuing, make it bigger when it's necessary. That stop processing is not efficient. So how many elements will be double the elements? So I try to make this one only as a animation, but it turns out it is. Okay, how many times will it double the n elements? So it says log to n. Why is it log to n? So in a computer science world, if you talk about doubling it, halving it, doubling it, halving it, it is all about log. Okay, so let's think about how many times will we double for n element? Of course, if I have 2, it will be 4, it will be 8, it will be 16. How many times did I did? 1, 2, 3, 4 times. So log 2 to 4. 4 times. That's what I meant. Okay, simple. Maybe too simple for a senior like you guys. Okay, next is pointers and linked structures. So we just talk about the contiguous data structure. Now we talk about the linked structure. Do you understand the pointers? In the C language, we cover the pointers, right? I assume you understand what is pointer, right? Who's not clear about the pointer? Am I disconnected?
No.
Hello? No? Okay. So everybody understand the pointer. Can I assume this?
Yes.
Yes.
Yeah, right. So not completely understand, but you know what it is. Oh, pointers.
Someone said no in the chat.
Okay, thank you. So a cell phone number can be thought of as a pointer to its owner as they are moved out of the planet. Meaning, so my cell phone number, so let's say Seung-Jun Lee, SJ. SJ's phone number is right, something like this. Okay, whenever I want to call SJ, I push this number, then this number is assigned to this device. Then this device is pointing to this device, then I can connect it. Okay, so in C, so star P or asterisk P denotes the item is pointed by a P and ampersand X or and X meaning the address of it and particular value of X. I assume you understand what it is. So a special null pointer value is used to denote the structure, terminating or unassigned pointer. Okay, so let's see the linked list structure. How does it look like? So do you understand what it is? The item is item, structure list is next. That's a basic linked structure. So the value and this one. So next I have to assign Obama, then next I have to assign the next value, then whole pointer is assigned. So can I assume you understand linked list? I don't think I need to explain about what is linked list, right? Okay, so searching a list. How can you search a list? I want to find Obama in a given text. I want to find Obama in a given text. How can you find? You always start from here, check the value. If not, go to next. Go to next meaning this value's next value, okay? keep finding it until you find your target value. Oh, I just found it and I know where it is. Okay, see the value. Search list, and I'm looking for X. If is null, meaning if your list is empty,
방제실에서 안내 말씀드립니다. 지구 후 태풍 마이삭이 우리나라를 향하고 있어 태풍 피해 우려가 있습니다. 캠퍼스 거주자분들께서는 다음과 같은 사항을 주의하시어 피해가 없으시기를 바랍니다. 각 사무실 창문 및 복도 창문은 태풍에 날아갈 우려가 있으니 모두 시건하여 주시기 바랍니다. 바람에 날아갈 물건이 주변에 있다면 미리 제거하거나 방제실 및 캠퍼스 근무자에게 신고하여 주시기 바랍니다. 마지막으로 인명사고에 우려가 있사오니 외부 활동을 자제하여 주시기 바랍니다. May I have your attention, please? This is Incheon Global Campus Emergency Office. As the Minap Typhoon Maysak is heading towards Korea, we need your cooperation to prevent damaging the campus. Please close all windows in the building and put away things that may blow away in the wind. If you find any issues that should be taken care of before the arrival of typhoon, please report to IGC Emergency Office. In addition, please minimize outdoor activities for your safety. Thank you. 인천 글로벌 캠퍼스 통합 방제실에서 안내 말씀드립니다. 지구 후 태풍 마이삭이 우리나라를 향하고 있어 태풍 피해 우려가 있습니다. 캠퍼스 거주자분들께서는 다음과 같은 사항을 주의하시어 피해가 없으시기를 바랍니다. 각 사무실 창문 및 복도 창문은 태풍에 날아갈 우려가 있으니 모두 시건하여 주시기 바랍니다. 바람에 날아갈 물건이 주변에 있다면 미리 제거하거나 방제실 및 캠퍼스 근무자에게 신고하여 주시기 바랍니다. 마지막으로 인명사고에 우려가 있사오니 외부 활동을 자제하여 주시기 바랍니다. May I have your attention, please? This is Incheon Global Campus Emergency Office. As the Minap Typhoon Maysak is heading towards Korea, we need your cooperation to prevent damaging the campus. Please close all windows in the building and put away things that may blow away in the wind. If you find any issues that should be taken care of before the arrival of typhoon, please report to IGC Emergency Office. In addition, please minimize outdoor activities for your safety. Thank you.
okay. So searching list. If you keep looking for the item, if you find, return the item, return its value. If not, you keep looking for next. Okay, I'm sure you understand this. This is how you insert into a list. So you don't need to maintain the order. So I can insert to the head of the list simply, right? So you make size of P, size of list, and P's item is X, you just update it, and P's next is starting point of the list. Then you make P point as a starting point of your list. That is how you insert into a list. Okay, deleting it. How are you deleting it? So you keep looking for the value. Oh, I just found it. I want to delete it. Then you're maintaining the previous one. Then previous next is directing the my next is how you're deleting a list. So if you look at it, so while you keep looking for, meaning you keep maintaining the last one. I have to know what is my last, what is my previous. Then if you find it, P's next, my next, my previous next. Okay, my next. So I know who's my next, right? This value is updated to this value. So my previous next is my next is next. Okay, this code says in that way. Okay, I'm sure you understand this pretty simple code. Any question about it? Okay, so let's solve this problem. How long does it take for search? How long does it take in insert? How long does it take delete? And min and max and successor and predecessor in unsorted array? How long does it take? So you understand what is unsorted array. Okay, so I'm gonna pick someone. Okay, I'm gonna ask Ko So-young, Lee Min-hang, Lee S.J., Sung-jun, Lim Han-min. Ready? So-young, can you answer this question?
Guess for first one, it's ON. Then
Why? Why? Just explain why you choose this.
because it's conjured.
Why is it big O-N?
Because it's conjured, so it takes like ON time.
Okay, Min-han?
Yes.
Okay, I think you guys know the answer, right? In the PDF, it says the answer. And why does it take a big O-N in a search of unsorted array?
It's a worst case.
So let's say unsorted array ten, 9, 7, 2, 1, 8, 6, 2, 6, 3, 4, 5, and you want to add the number 12. How long does it take? You want to search the value, search value 3. How long does it take?
N.
And why?
Go on. We are considering the worst case.
Yeah.
So in the worst case, number 3 is located at the end. So it iterates n times.
So search meaning in unsorted, you have to keep finding it. What if it is sorted array?
Then it's log 2n.
Still same.
Han-min, Min-hang, please.
It's gonna be O log n.
Is it Min-hang? No, why is
Yes.
it mark is changed?
It's Min Heng.
Okay, Min-hang. Okay, why? Why is it log n in a sorted array?
I think it's
I don't
still
know.
n.
It's because of binary search.
Yes.
Yeah, but professor didn't specify which search that is.
So let's simplify. I have unsorted array and sorted array. Okay, so I want to do search. In unsorted search, it takes big O N because I have to keep reading from the start until you're finding it, right? If
Yeah.
it is sorted array,
You start at the middle.
start at the middle,
Yeah.
then
And
left
check what-
or right, right?
Yeah. And
Then you can halving it.
yeah,
Therefore, it is log n.
log 2n.
Yeah, thank you. Everyone understand? Is it Min-hang's voice? Min-hang's voice?
Yes.
Okay, thank you. So you just answered the halving it? Also, mic is changing. Yeah? All right, who answered my last comment? go to the halving. Was it Minheng? Okay.
I
Well,
think it was
anyway.
Youngjae who was saying. I thought.
Youngjae? Okay.
It was
Thank
me.
you. Okay. You are Youngjae, right?
Yeah, 영재문.
Youngjae, how can I don't have Youngjae Moon? Okay. Thank you. Then everybody understand why can I do log n and big O n in a search? How about insert? In unsorted, let me. Linked list, double linked list. Okay. So can you specify 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So I have a 20 mark. I'm sure you guys are able to answer this question, right? So we know what it is. It says big O n unsorted. In the sorted, search is log n. Okay, insertion. Where is it? So let me pick Jonghoon and Subin and Yejin and Yongho and Adrian and Taeyong. I'm going to pick in sequentially. So let's start with the Jonghoon. What's the answer for unsorted array in insertion?
Is O one time and O n time for sorted array.
Right. So can you explain to us?
Because we can just put an element at the beginning of the unsorted array, but in sorted array, we need to search the proper place for the elements to,
Okay.
so in the worst case, we need to travel whole n elements, so it is O n time.
Okay, thank you. I think he marked perfectly. So everybody understand this? So in the unsorted array, to insert it, you have to just put it ahead. I don't need to worry about the sorting order. But in a sorting array, I have to find the right position and I have to move every element after this in one point. Then I can put it. Therefore, it is more complex. Okay. How about delete? How about delete? Okay, I'm gonna pick Subin.
For the unsorted, I think is O1. And for the sorted, I think that's ON.
Can you explain?
If we delete something in an unsorted array, can just fill that place with some other one. But in sorted array, we have to move everything to make it in order.
Okay, perfect. Thank you. Everybody, I assume everybody understand clearly. Okay, Yejin, what is the min and max? How long does it take?
For unsorted array, I think it's ON. For sorted array, it's O1.
Okay, can you explain to me?
For unsorted array, we need to check every element to find the maximum and minimum.
Okay.
For sorted array, the minimum element can be inserted at the first spot, and then the maximum element can be inserted at the last spot.
Okay, perfect. Okay, Son Young-ho, what is a successor and predecessor in the unsorted? array?
For unsorted array, it's ON. And for sorted array, it's O1.
Okay, can you explain to me?
Because in unsorted array, if we have an X, then since it is not in order, we have to go through the whole array to find both successor and predecessor. But in sorted array, if we know the exact index, then it is index -1, and index +1 is for successor and predecessor. So
okay, perfect. Oh, okay, I'm sure you understand the point. Thank you all. So go back to the point where we discussed. And advantage, now we move on to the list, linked list. We understand what is array, and now we move on to the list. So relative advantage of linked list is over the static array is overflow is never happen. Without actual memory is happen. Actual memory is full, okay? And insertion and deletion are simpler than contiguous array because I don't need to push everything to one time, then I can put in the right addition in the array. But in the linked list, we don't need to do that. Just moving the pointer. So with large record, moving pointer is easier. So with large record, moving pointer is easier and faster than moving items themselves. Let's think about it. This array is a big size, and let's say it is sorted. Oh, I want to add this one, and rest of it. Then if I want to add new value in here, meaning I have to move everything from here to here is shifted by 1. Then I can put in here. It is only adequate when the size is small. When it's large, you can't do this. Therefore, in a big size of file, the linked list is more adequate. And dynamic memory allocation provides us flexibility on how and where we use our limited source resources. Okay, we're going to discuss about it. So I'm sure you understand what is singly and doubly. Singly list means I know who's my next, but I don't know who's my previous. Double linked list, I know who's my next, and I also know who's my previous. Okay, so extra, the cost of the this one is almost 0 because I'm only maintaining one more pointer. So you can maintain a double linked list without many cost, without that much cost. And the singly list to double linked is conga line to the cancan line. Do you know what the conga line is? If you go to the festival, everybody dancing on someone's shoulder and do this. It's like in Korean, it's a kichanori. It's a conga line. And cancan is you dance together and shoulder to shoulder, and left foot, right foot, everybody, left foot, everybody, left foot, right foot, everybody. Cancan dance. Okay. Not that important. Okay, stack and queue. And sometimes the order in which you retrieve data is independent as content. So being only one function where it arrives. So push and pop in the stack, we know what the push and pop. In the queue and NQ and DQ. Stack, we represent it this order. First in, last out. Queue, we usually use this one. And first in, first out. Okay. So stack and queue implementation. So stacks are more easily represented as an array with the push-up, pop incrementing and decrementing a counter. So queues are more easily represented as a linked list with NQ and DQ operating on opposite ends of the list. So all operation can be done one time and a constant time for both structures with both array and the list, and push and pop. So why stack and queue? Why do we using this? Stack and queue, both are appropriate for a container class where order doesn't matter, but sometimes it doesn't matter. When it doesn't matter, and when the size is small, we can use the array. When the size is big, we can use the list. So we can use a queue. Okay, so lines and banks are based on the queue. Food in my refrigerator usually is a stack. Okay, so what is important? The first one, if the latest information is important, then I can use a stack. If the information which comes first is important, then I can use the queue. The entire difference between DFS and the BFS is whether stack or queue holds of vertices items will be processed. So you understand what the DFS, and I'm assuming you understand what the BFS is. Something like this. Let's say I want to do BFS. What's the sequence of it? I have A to J. If I use a BFS, if I use a DFS, what's the sequence of processing? Anyone else? Let's say Adrian, Timothy.
Oh, yep. I'm
Yeah,
here.
next one will be Taeyong. Can you do BFS, please?
For DFS, so it goes from A to B, then to
You
E.
you want to pick the DFS first? Okay. A.
Yeah, DFS. It goes from to B, then to E. So it goes to E first. And then it goes to F. And then it goes back to B. And then it goes to C, and then it goes to the next one, which is G.
Yeah.
Then H, back to C, go to the next one, D, goes to I, J, back to D, then goes to A.
Okay, thank you. Okay, Taeyong, how can we handle the BFS in this case? What's the processing sequence?
We go for A, B, C, D, and then E, F, G, H, I, J.
Okay. Oh, you knows all the algorithm, guys. Thank you. Maybe it is too easy in first week and second week lectures, right? So I assume you understand what is a BFS and a DFS. Thank you thank you for the clarification. So do you understand what the dictionary is? Okay, so dynamic set operations. Perhaps the most important class of data structure maintain a set of items indexed by a keys. Hash function it is. So I want to find the SUNY Korea at Google. How does Google works? In Google, you type in SUNY Korea, and how can Google find in less than a second and able to find my website? How? Because the data is mapped into a hash function. Okay, then they are dividing to word, SUNY and Korea. Okay, or one word. So they are making in alphabet order, A to B, jet, and 0 to 9. And A, there's again alphabet order. C is all alphabet order in some order. So let's say I'm looking for something, then SUNY Korea goes to there. From there, you're able to find it. All this process, you can go directly to S is set of operation, we call the dictionary. Okay, even if it's very complex one, you are able to find the word with the 7 steps. Okay, go back to the point. So search. you're looking for a search value K in your set S, okay? A query that given a set of S and the key value is a K returns a pointer of X element S such that this one. What does this mean? So I have dictionary and I go to the pointer, I go to the key, in there is a value. In there is a value. In there is value. Oh, hash. Okay. Search in the dictionary. Okay, I understand. You're looking for key value of it. Okay, just found it and return the value, corresponding value of it. Okay, so insert a modifying operation that augment the set with the element X. I can add it to a new function following my hash key, and delete is given a pointer X to element S that remove element from your set. And observe we are giving a pointer to element X, not the key value. We are not able to delete the key value, but we are able to delete the key value of it, not the actual value of it. So min and max returns element that are totally ordered S, which has the smallest or largest key. Okay, so logical predecessor and successor given an element S, X, whose key is from a totally ordered set and returns the next smallest or next biggest element in S, or nil if the X is the maximum or the minimum. There are a variety of the implementation of these dictionary operations, each of which yield the different types of bound for various operations. So there is inherent trade-off between these operations. We'll see that no single implementation will achieve the best time bound for all operations, meaning based on the environment, based on the data size, it will be the optimization will be different, okay? So we understand what it is. We have ability to mark it. So if I quickly go through, so search in array, which is unsorted, meaning I have to search it all array, then I can find it. Therefore, big O N. In insertion, oh, I can make it in one shot. I can put it at the first or last one. Or anything that is empty, I can put it there. So delete. In an unsorted, I want to delete this guy, meaning I'm copying the last value to this one. I can do this in a one time. Min and max, oh, I have to check it and maintain who's a mean. At the same time, I can do a max. And successor and predecessor, meaning I want to know successor value. I want to know 8, 7 successor, or predecessor is a 6. I want to find the largest one who is smaller than me. I want to find the smallest one who is bigger than me. Okay, that is a successor and predecessor concept. Then in a unsorted array, I have to search through, then I can find the target value. If it is sorted, now it is different story. If it is sorted, your values are sorted, meaning search, then I can go there, okay. This value, oh, I have to go to the left or right, I can make decision. When I go to left, I'm not going to the right before, but I'm going to the middle point. I'm going to the middle point. That is a concept of halving it. My search, go to there. If I make a decision, go to left, meaning I can ignore half of it. From there, I can ignore half of it, meaning binary search, which is log n, okay? And insertion, if it is sorted, I can find, okay, then from here, I can make a couple of steps, meaning I can do sorted array. If I want to insert, how can I do? I want to insert 6 in this value. Then meaning I'm looking for this with the big O N, okay, this is right point. Then what can I do? Then everyone after me is shifted by 1, then I can move in. It takes a while. So I have to shift every value after me. Therefore, is a big O N. Delete. In a sorted arrays, move to fill up the hole. So meaning if I want to, in a given array like this, I want to remove 7, meaning 1, 2, 3, 5, 1, 2, 3, 5. Okay, 7, meaning after me has to come one time shift. That I have to shift everyone else after me. Therefore, it is big O N. Mean and max. Oh, I know what is mean. I know what is max instantly. Successor and predecessor. Successor of 7, oh, it's 5. Successor of 7 is 8. Predecessor of 7 is 5. I can instantly know because it is sorted. Okay, so we can do this with the linked list in the next lectures. Any question about today's lecture?
Nope.
No, too easy? So in the first half of this semester, I want to quickly review what we know. And after that, I try to do pushing the limit, push the edge, okay? So for CSE373 is made for understand the dynamic programming. And if you understand the dynamic programming properly, it will be very helpful for your job search and job interview. Okay, any question about the homework? Homework will be like this pattern, what you did in the Google Classroom. Some of you told me that, oh, I did submit, but it's not actually submitted. I'm sending this capture. Okay, this is accepted it because it is first time, and don't make a second mistake. And the TAs are working very hard to score it properly. And I think he did it very fairly. And I think he's very good at the 373. So if you have a question, I cannot do by myself, then maybe you can ask to the TAs too. Okay, so I'm sure you know the TA's email. And in the Google Classroom, there is a TA is assigned. So if I'm sharing team is our TA. 대경 B. So he is our TA, Tim Kim, and he usually stay in the campus. Okay, so Hyungtaek-Kwon will post it today. What is posting today? The homework number 2 will be posted today, yes. Any question?
Professor?
Yeah.
Just one quick question on the deletion of an unsorted array. You say it's O1, right? We can just copy nth item to the X spot. That's just placing some other element to the nth item, right?
So you mean delete in the unsorted array?
Yeah.
Okay, how can I delete the number 9? So
what I thought is that.
So nth item X position. So position is known, right? Nth item means that the last value. X spot meaning I know where the value is. So delete. The searching process is not counted in this case. So I want to delete 9. I know where it is. So to find where it is, I already searched. Okay. And from there, how long does it take in a deletion? So the last element copied to this. Then I just delete the 9. Then I can make one integer value smaller array. Then I can declare this is my array. Or that the last step doesn't need to. So I meant this value, this process, it takes one time.
Okay.
Clear?
I thought we had to include the searching time as well.
No, so deletion, what I meant, so you are correct. If in an unsorted array, delete number 9, meaning I have to find the 9, then I can delete it. But in this case, delete the position X the position spot. Okay, then we can clarify with this one.
Okay, okay, thank you.
All right, thank you. So, okay, that was a good question. Thank you. So, who was this?
Hassan, Chan.
Hasong. Okay, thank you. So wherever you raise your voice and if it is meaningful, I always give you the point because the interactiveness is the key in the online class. Okay, thank you. Any other question? No? Okay, so you will have a second homework today and it will be fun and enjoy it. If you have difficulty to do your homework, and please consult your friend. If not, maybe you maybe contact the TAs, and he knows all the he has all the solution for this, and it will be very helpful if you contact him. And this is very good chance to make a friend. Okay, so who has no partners yet? So first homework and second homework will be easy, but then later it will be more tough and tough. If you don't have a friend, if you don't have a fellow to 373, this is a good chance. Who wants to have a friendship? Who wants to find the fellows? Raise a voice. This is the time. Nobody?
I don't mind.
You don't mind, meaning you don't need?
No. I mean, no. I mean, like, if anyone wants to do it together, then I'm open.
Okay. Can you put your name on the chat?
Okay.
So Janar, everyone, who wants to talk to Janar for your homework? Nobody? Don't be shy. Being shy doesn't help you at all. Okay, Sungjun, okay, this is how it works. I just did a matchmaking. Anyone else? Okay, you can also post your name on the Google Classroom in a stream and looking for partners to discuss. Okay, then you can have a good partners to think about this 373, think about the algorithm. Okay, this 373, the algorithm analysis algorithm is a pinnacle of the computer science. The class should be must be very fun, and I hope you enjoy the class. Okay, this is not memorizing, but you have to think, use your brain and teasing your brain. That's the goal of the analysis of algorithm. Okay, all right, any comment? No? Okay, thanks for coming today. Let me close the call off the class today 10 minutes early.
Thank you, Professor.
Right. Thank you guys.
Thank you, Professor.
Thank
Yeah.
you.
Thanks.